Hi, everyone. This is Math 35. It's college algebra at College of the Sequoias in Visalia, California, Tulare, California. We are in spring 2020 COVID-19 lockdown. I'm building these videos for now and for future semesters as algebra and geometry have not changed in a really long time, but we do have tools like computer programs that can enhance it, and I will show some of those as we're going. This section is on Chapter 10, Analytical Geometry. Analytical geometry, things we've seen before. We've seen parabolas and circles, things like that. I'm sure you've seen an ellipse before. Hyperbola, there are images of these in real life. And there's pretty good stuff out there. And they all come from taking an hourglass figure, or basically two cones like this, putting the points to each other, and then taking a plane, a solid sheet of metal or something like that, and intersecting it. So the parabola comes from intersecting one cone at an angle. The hyperbola comes from doing a vertical chop through both cones. Circle is a horizontal chop through one cone. And an ellipse chops through a cone all the way through, but at an angle. They each have their different equations, as we're going to explore today. Parabolas you've seen. We've seen parabolas in the form, recall, we had y equals a times x minus h squared plus k. This opened upwards if a was greater than 0. It opened downwards if a was less than 0. And this point right here, the vertex for either of them was the point HK. Now we're going to explore doing something new. Okay? Let's look at sideways parabolas. Sideways parabolas come in the form x equals a times y minus k squared plus h. Vertex is still hk. If a is greater than 0, it opens to the right. If a is less than 0, it opens to the left. Our vertex is there or there. And another form we often see this in is if they subtract h to the other side, they have x minus h equals a times y minus k squared. Okay? So let's take a look at an example. Maybe we can go to the next page. So I'm going to rewrite that equation just so we can clear things up. And our example, we're going to have x minus 4 equals negative y plus 2 squared. So the first question is, what is the vertex? Well, here, these two must match up, which tells me h equals 4, because the minus signs already match. Here, the minus sign has to change to a positive, so that means k has to be negative 2. And we get a vertex at 4, negative 2. A is negative 1, which means it opens to the left. And where we used to have y and x squared, and x and x squared equaled y, and we either went left 1 or right 1, we went up 1, and we went left 2 or right 2, and we went up 4. What happens here is the order switches. The base thing for x equals y squared, if this goes up or down 1, when a equals positive 1, this goes right 1. And if this goes up or down 2, this goes right 4. And also up or down 3, this goes right 9. The a equals negative 1 is going to flip this. So let's graph this by hand. Our vertex is at 4, negative 2. If I stick in y equals 0, y equals 0 will give me my x-intercept. So I've got x minus 4 equals negative 2 squared. X minus 4 equals negative 4. X equals 0. I have an intercept at 0, 0. Looks like it's a y-intercept as well. The reason why is we are going left and we're going to follow this same trajectory. If I go up or down 1, I need to go left 1. If I go, and that's the same with down 1. If I go up or down 2, I need to go left 4. That makes this line right here our axis of symmetry. And we can connect the dots. Remember to make it nice and rounded at the end. It's not a point. And what maybe we could look at a couple other things. What's the domain here? What's the range? Well, it looks like if we start on the left, the domain starts at negative infinity and stops at x equals 4. If we do the range, we start at negative infinity. This line will keep going down. We keep going up, and it keeps going up. The range is infinite. Is there another way we could have found this point right here? Yes, there is. That's a y-intercept. X equals 0 there. We could have set that equal to 0 and solve. In fact, let's do that on the next page. Let me rewrite the equation. And we're going to do x equals 0 to find the y-intercepts. Negative 4 equals negative y plus 2 squared. I'm going to multiply both sides by negative 1. That just changes the sign. We get 4 equals y plus 2 squared. We'll take the square root. And I get plus or minus 2 equals y plus 2. Subtract 2 from both sides, and I get y equals negative 2 plus or minus 2. The top one gives me -2 plus 2 is 0. The bottom one, -2 minus 2 is -4. My x-intercepts are 0 or 0. I'm sorry, my y-intercepts are 0, 0, and 0, -4. It intercepts the y-axis twice. And we can see that in our graph, right? See that? Good stuff. We don't have to necessarily have it in this nice little pretty form. So let's look at one where it's not set up so pretty and maybe rewrite it so that it is. Let's do x equals 1/2 y squared minus 4y plus 6. And I want to make it look like x minus h equals a times y plus or y minus k squared. So the first thing I'm going to do is I'm going to move the 6 over, so I'll have that constant on the other side. If I do that, I'm going to factor out the y 1/2 right now as well. What I'm doing is I'm doing dividing each of these by 1/2. -4 divided by 1/2 is the same thing as -4 times 2 over 1. Instead of dividing by a fraction, we can multiply by the reciprocal. This is -8y. And I'm going to leave a blank. This allows us to complete the square. Yeah, I told you that would keep coming back. So what do? We take this, we divide it by 2, and we square it and put that back in. -8 divided by 2 squared is -4 plus 2, or squared, -4 squared is 16. How much have I actually added to the right side? I didn't add 16 because of that 1/2 right there. I added 1/2 times 16, which is 8. To make up for that, I'm going to add 8 to the other side. So down here I have x plus 2. And we've got the 1/2. And remember, when we complete the square, this thing comes down. This thing comes down. -8 divided by 2 is -4. That turns into the square. So that's our complete the square. Now we've gotten this written in the other form. So I'm going to pause it, let you jot some stuff down. Okay. Let's take a look at graphing it and discuss some other things. So let me rewrite the equation. First off, what's my vertex? Remember, this is -h and this is -k. If that's the case, -h, this is +2, h has to be -2. K has a minus there. This already has a minus. Looks like k is +4. A equals 1/2, which means it's going to open to the right. And let's see how much it scales it. So we used to do up or down 1, up or down 2, and up or down 3. Squaring that made it right 1, right 4, right 9. But now we're going to multiply that by 1/2. And this turns to right 1/2, right 2, right 4.5. I think moving by 4.5 and stuff like that's a little bit harder. Let's just find the intercepts. Our vertex is at -2, 4. We know it opens to the right, so we're going to have an axis of symmetry right on that y = 4 line. And we can use that to plot points once we have the intercepts. So the y-intercepts are when x = 0. And let's see, is this one easier to do right here? Yeah, let's just do it here. If I do it here, I've got 2 = 1/2 y - 4 squared. I'll multiply by 2 on both sides to get rid of that fraction. And I get 4 = y - 4 squared. If I take the square root, I get plus or minus 2 equals y - 4. And we add 4 to both sides. Y = 4 plus or minus 2, which means 4 plus 2, y = 6 is a choice. 4 minus 2, y = 2 is a choice. That's when x = 0. Our intercepts for y-intercepts are 0, 6 and 0, 2. That's got some symmetry. In fact, if we look at the 1, 1/2, let's find our x-intercept. I have x plus 2 equals, I'm going up here, I'm just plugging in y = 0, 1/2 times -4 squared. -4 squared is 16. X = 6. That's when y = 0. We have an x-intercept at 6, 0. How far down is this? It's down 1, 2, 3, 4. So I can go up 1, 2, 3, 4 and put another point up here using symmetry. And finally, we now connect the points in a nice little pretty arc. Okay. So I want to go to something new. This is still parabolas. Okay. This is still parabolas, but we're going to expand on it. What is a parabola really? A parabola, this is the actual definition of a parabola, is the set of points in a plane that are equidistant, which is a short way of saying equally distant. I'll write that because it might be a new word for you. Equally distant. From a fixed point and a fixed line. The fixed point is called the focus. The line is called the directrix. And between them, halfway between, well, it's easier to see. Actually, let's show you in Desmos first. Desmos is going to make it look pretty. I'm going to screw up the graph and make it look terrible because it's just not easy without graph paper. And I know you all don't have graph paper, so I'm going to try to show it to you. Desmos has this neat stuff in it. I don't know if you're aware of it. You can click on Open Graph, and all of the graphs I have at top are ones I've saved. If you go all the way down past it, they give you examples. We've got parabolas in standard form, vertex form. We get down to the conic sections. It even is, look, it's got those. Oh, this is for trigonometry. I should have loaded that up for trigonometry. Conic sections, parabola. I open the graph and look what it gives me. It shows me the picture of a parabola. This is y equals x squared. This here is the focus. Let's see if I can change the directrix color. So this is what they mean by equally distant. This point right here, 4, 4, is equally distant from this point right here and drawing a perpendicular line or a line that's straight onto the directrix that's perpendicular. So let me try to illustrate this on the graph. What do we got here? That is not y equals x squared. Let's make it y equals x squared. Oops. I don't think I have number lock on. That's the problem. There we go. That's a parabola of y equals x squared. 1, 2, 4. That looks a little bit better. This is y equals x squared. The focus is right there. And this is the directrix right here. So the idea behind it is if like I connect this point here, here, down to here, let's say that's D1, that's D1. If I go here to here, and I draw a line so it makes a perpendicular line down here. If this is D2, that's D2. It's the same distance. This focus and directrix have a very specific position. Okay, so let's explore that. In fact, they even give it right here. So a parabola with a focus at 0p and directrix y equals negative p. Have the equation. There's two ways of writing it. One of them we see in Desmos right now. Y equals x squared over 4p. Or we can have x squared equals 4py. Okay. If p is greater than 0, it opens up. P is less than 0, it opens down. Okay. And we'll work with this in a second. If we want to do a sideways parabola, we're going to have y squared equals 4px, or x equals y squared over 4p. Here, the focus will be p0. Directrix is x equals negative p. And if p is greater than 0, it opens rightward. If p is less than 0, it opens leftward. I think that one's a little bit better to have as a dotted line. Okay, so let's explore this a little bit. Let's practice working with these. So first example, A, we've got x squared equals negative 4y. And our goal is to find the focus, vertex, axis of symmetry, directrix. that should be good. So we've got x squared equals negative 4y. This is the same thing as x squared equals 4py. This is the best approach of doing it. And now that has to match that. So negative 4 has to equal 4p. We divide by negative 4, and we get p equals negative 1. This was an x squared one. X squareds normally open up or down. P equals negative 1. It tells me it's opening down. My focus is at 0p. And in this problem, that's 0, negative 1. My directrix is y equals negative p. Negative p is negative, negative 1. We get y equals 1. And something else I didn't show you, I will when we're doing, okay, axis of symmetry. Let's sketch what we got. My directrix is at y equals 1. My focus is at 0, negative 1. My graph opens down. What I failed to show you before, and I need to bring it up right now. This is as good a spot as any to do it on this graph. At the focal point, if it's x squared equals 4py, go left or right the absolute value of 2p. So in this problem, p is negative 1. So 2 times negative 1, absolute value is 2. I'll use blue for my actual graph. Red's my focus and parabola, or focus and directrix. And that allows you to have something to connect right there. So that's what I was saying right here. This distance here is the absolute value of 2p. So is that distance there. Let's explore it in Desmos. They had p equals negative 1. And do we have what they have? We have our directrix at y equals 1. We have our focus at 0, negative 1. And this is what I was saying. Notice if I go left or right here, I'm going over 2. That's a point on the line, 2, 1, or 2, negative 1. And we've got over here 2, negative 1. It's exactly 2 times p, the absolute value of p, left or right, okay? That's this speeds up the graphing. A lot. A lot. Okay. So let's take a look at another one. Here we're going to have y squared equals 12x. Okay. So here we've got y squared. Y squareds tell us it's going to open right or left. Let's figure out what p is. That'll help us decide which way it is. This should coincide with y squared equals 4py, or 4px. Which means 12 equals 4p, p equals 3. P equals 3 says it's opening to the right. That 2 times p is going to be 6. I don't know that I said the name for it either. This is called the focal width. Okay. So let's give it a sketch. P equals 3, which tells me on this left or right thing, I have a focus at P0, which is 3, 0. Directrix is x equals negative p, which is negative 3. So my directrix is back here. My focus is right here. This focal width is 6. And I need to go up 6 and down 6. The line for focal width is always parallel to the directrix. So I could say, I could make a parallel line to the directrix. This shows me my focal width is going that way. But now I've got points. Okay. We can go the other way. Let's take a look at this one first. P is 3. And now we want x equals negative p. We'll turn off that one. And now we can see what's going on here. Oh. That was kind of neat. See how the arrows tell you which way the axis of symmetry is going. So we can see it here. We've got p equals 3. We put that in. Does that work? Putting in 3, 4 times 3 is 12. Y squared equals 12x. That works. We've got a directrix at -3. X equals -3. If I go up and down from the focus, it's hitting at 6 and -6. And so that's a good sketch of the graph. Okay. Let's play a little bit more with this. So here, write an equation for each parabola with vertex at the origin. A, the focus is at 0, 3/4. So if it helps, sketch a little picture. My focus is there, my vertex is here. The parabola opens towards the focus point. So we know it's going upwards. This tells me that the squared term is x. So we're looking for something like x squared equals 4py. Where is p? Well, this was p. So let's just put that in. The 4's cancel and I get x squared equals 3y. Or if we want to write it like normal people do, we'll divide by 3. Y equals 1/3 x squared. Let me have you give it a try. Let's see what you come up with. Parabola has a horizontal, well, maybe this one's a little bit more complicated than the last one. We should do it together. Has a horizontal axis of symmetry. Vertex at the origin. And passes through -4, -8. Okay, so what does that mean graphically? Horizontal axis of symmetry. I've got a vertex at the origin. and it tells me there's a point at -4, -8. The axis of symmetry has to be the x-axis, which means there needs to be a point at -4, +8 also. So this is -4, -8. This is -4, +8 by symmetry. So I know the graph is opening that way. Right? How do we find the equation though? This is a graph. Since it's opening left or right, this is a y² equals 4px graph. Why don't we just put in -4, -8? To find p. So y² is -8 squared equals 4p times -4. -8 squared is 64. 4 times -4 is -16. And if I divide both sides by -16, I get p equals -4. Which means I can put that right up into there, and it spits out y² equals 4 times -4, -16x. Or if we divide by -16, we could say x equals -1/16 y². Okay, ready for some more? We've been looking at when the vertex is at 0, 0, the origin. What about when the vertex is hk? x² equals 4py changes to x minus h² equals 4py minus k. Y² equals 4py changes into y minus k² equals 4px minus h. P is now the absolute value of P is now the distance from the vertex. Okay? So let's take a look at an example. Write an equation for the parabola with a vertex at -2, 3 and a focus at -2, 2. Okay, so pro tip, plot it. Plot what you know. Plot what you have. Let's see. My focus is here. My vertex is here, which means it's got to be opening downward. What is this distance right here? How far apart are they? They are 1 apart. So our P has to equal either plus or minus 1. It's going downward. I would argue -1. Which means we have a directrix up above like that. And then now let's write what we have. This is opening downward. This is an x squared situation. So up or down, we need the x squared. Left or right, we need the y squared one. So what was our x squared one? We've got x minus h squared equals 4p times y minus k. What's h here? They actually give it to us. That's h. So I plug in h is -2. I get x plus 2 squared equals 4p times y minus 3. And now I've identified p is -1. 4 times -1 is -4. And that's the equation of that line. Let me give you guys one to try. Let's do the focus is at -1, 3. Vertex is 1, 3. Find the equation and graph it. All right. I'll assume you paused and did it. Let's get a little bit of a sketch going. It'll inspire us. What do we got here? So that's my focus. My vertex is here, which means it's opening left or right. P should be negative. This width right here, how far apart are they? 1, 2. That's got a width of P, absolute value of P equals 2. And I know it's negative, it tells me P should equal -2. It's opening left or right. This is a y squared scenario. So y minus k squared equals 4p x minus h. I know my directrix is exactly the same distance away on the other side of the vertex. My vertex is 1, 3. That helps me. That's my HK. So K equals 3. H equals 1. And I just identified P equals -2. Four times -2 is -8. How much is absolute value of 2P? Is 2 times -2 is 4, which means I need a point that's up 4 and down 4 from that point. And if I wanted to be more accurate, I could be more accurate graphically. If I found my intercepts. And just to make sure we illustrate that, let's do that. So when y equals 0, we have x-intercepts. Plugging in y equals 0 gives me 9 equals -8 times x minus 1. So 9 equals -8x plus 8. Subtract 8, and I get 1 equals -8x. So x equals -1/8 when y equals 0. And I have the point -1/8, 0. Apparently, this should have crossed right about there. So my sketch wasn't super accurate. It was pretty close. My y-intercepts is when x equals 0. I have y minus 3 squared equals, if I plug in x equals 0, I get -8 times -1 is +8. So if I take the square root, y minus 3 equals the square root of 8, which is 2√2. And that's plus or minus. So y equals 3 plus or minus the 2 square root of 2. 2 square root of 2 is approximately 2.7. So I get y equals 3 plus 2.7 is about 5.7, or subtracted about 0.3. So we have 5.7, 0. And other way around, 0, 5.7 and 0, 0.3, which means this should have been a little bit higher right there. 3, 4, 5, and a little bit lower right there. Almost. Not a bad free-for-handing it, considering I was using the focal width. The curvature should look about right. And why do we care about parabolas? Let's just show you some examples in real life. There are problems in the homework that have you working on them. One example, real life scenarios. Well, headlights. the light bulb goes at the focal point. Focus or focal point. And the reason why that's optimal is that no matter which way the light shines, when it hits it, it reflects straight that way. So all light is focused forward. Then of course we have stuff coming straight down the middle. All light is focused in one direction. It's actually pretty neat, isn't it? Something else does a very similar thing. Satellite dishes do the same thing. They tend to be flatter though. They're, you know, much more wide like that. And it makes the, you know, the receiver stick out a little bit further. Or the transmitter. Same thing. That's going to bring us to a wrap for 10.1. Peace.